Hello everyone, welcome to the session number 9 on Introduction to Statistics. So we'll continue with our discussion on how to organize the data, right? So in the session number 8, so we started frequency distributions, and there are two types of frequency distributions, right? And in the session number 8 we are already done with the discrete class intervals. Okay. So in this session number 9, so we will continue these frequency distributions, and then here our main focus will be continuous class interval. So this is another type of frequency distribution. Okay. Okay. So yeah, so this is a brief about me. So this is my LinkedIn ID. So you can follow on LinkedIn. Okay. So these are all the ways we can organize the data, and we are already done with the qualitative data. So if anyone miss or anyone wanted to learn how to represent the data in the form of pie charts, bar graphs, Pareto charts, please go through my YouTube channel. There you will find all the videos, okay, with the examples. And also we are done with the tally marks, and our focus is now frequency distributions. In that also, in the session number 8 we are done with the discrete class intervals. Clear? So here our focus will be continuous class interval. Okay, so let us take one example. Okay, then I will make you understand how to write the data in the form of continuous class intervals. Okay, so as I said in the session number 8 only, there is no hard and fast rule how to decide what is the appropriate class size or class width, and what are the how many classes we should consider, what are the appropriate number of classes. Okay, there is no hard and fast rule. It all depends on the number of observations and the maximum value and minimum value. And we should keep it in only mind that common sense, you should not consider many number of class intervals or very less number of class intervals. That is the only one funda. Okay, so here, as I said in the session number 8, first you need to decide how many observations you have. Okay, and what is the maximum value and minimum value. Why? Because the total number of observations and the maximum value minimum value will give idea. Okay, so what is the appropriate class size I can maintain, and based on the class size I can take the number of classes. Okay, so here, as I said in the session number 8 only, generally we use class size 5 or 10, depends on the total number of observations. Okay, here also you can consider 5, there is no issue. But here for you to show that we can take other classes also, class sizes also. So therefore here I have taken class width as 7. Now here my class width is 7. What is the meaning of that? Lower limit to upper limit, I should maintain the gap of 7. Okay, and then I have maximum value 37, right? So if I want to include this maximum value 37, so if I take approximately 6 classes, 6 sevens are 42, right? So therefore I can take 6 classes. That is the common sense, right? So that's how we should proceed. Okay, so it's all depends with the it will come automatically with your practice, no issue. Okay, so here I have taken 6 classes, and these are all the classes. Now you just observe here these numbers, upper limit of first class interval to the lower limit of the second class interval. Okay, what did you observe? Now you tell me. So in the like discrete class intervals, we observe that these numbers are different, so that's why those are all they are said to be discrete class interval, right? So when there is a continuity, right, if the upper limit of the first class interval is becoming the lower limit of the next class interval, those kind of class intervals are said to be continuous class interval. Upper limit of first class interval should be equal to the lower limit of next or the consecutive next class interval, right? So then these kind of class intervals are said to be continuous class interval. Clear? That is the first observation, and that is the one main difference between the discrete and continuous. And the second thing you should keep it in mind, this is very very important. So in the session number 8, I said that whenever you have discrete class intervals, so we have class limits, both lower limit and upper limit, right? So in the discrete class intervals, both lower limit and upper limit are included. For example, 1 to 7, 8 to 14, these are all discrete, right? So now here both 1 and 7 are inclusive. Here also 8 and 14 are inclusive. Am I clear? But when it comes to the continuous class intervals, only only lower limits are included. So this is the very very important difference between the discrete and continuous class interval. Okay, so if any data point, suppose let's say I have a data point 8, so where we should consider, here also 8 is there and here also 8 is there, where should I consider? I should consider in the second class interval. Why? Because this 8 is here in the first class is upper limit, and this 8 is in the lower limit in the second class. So as I said, only the lower limits are included. So therefore this data point should be written in the second class interval. Am I clear? So this is the one very very important difference between the continuous and discrete class intervals. Okay, so now let us put all these data points into our class groups, class intervals. Okay, yeah. So okay, so now here in the first class group, what is the meaning of here? 1 to 8, 1 is included but 8 is not included. So that means you should consider all the data points which are equal to 1 and greater than 1 and less than 8. Clear? Okay, so let us consider all those data points. Count 1 to 8. So technically it is 1 to 7 kind. So 1, 2, 3, 4. So 8 is not included in the first class. Okay, you should keep it in mind. 1, 2, 3, 4, 5, 6, 6, 7, 7, 8, 8, 9, 10, 11, 11, 11, 12, 13, 14. Okay, 14, 14, 14, 15. So there are 15 observations in this class group, class interval 1 to 8. So now let's move to 8 to 15. So 8 to 15 means 8 is included now here, 15 is not. So therefore technically you should consider 8 to the numbers which are less than 15. So 8, 1 here, 2, 3, 4, 4, 5, 6, 6, 6, 7, 7, 8, 9, 10, 11, 11, 11, 12. Okay, so 12 data points. Okay, so next year 15 to 22. So 15 to 22, 1, 2, 3, 3, 4, 4, 5, 6, 6, 7, 8, 8, 9, 9, 9, 10, 10, 11, 11, 11, 11, 12, 12, 12, 13, 14, and 15. Clear? So here again 15 data points. Next year 22 to 29. So 1, 2, 2, 3, 4, 4, 4, 5, 6, 6, 6, 6, 7, 8, 9, 9, 10. Okay, so 10 data points. Next to 29 to 36. So 29, 1 here, 1, 36, right? So 2 here, 2, 2, 3, 4, 5, 5, 6, 6. So 6 here. Okay. Next 36 to 43. 36 to 43, 1 year, 2 year, 2. Okay. These are all the data points, right? So when you count these again, the frequencies, you must get a 60. Okay, so in our case it is becoming 60. If you don't get a 60, then you should recheck. Okay, is there any data point or data observation left out, or we mistakenly put one data point into other? Okay, so you should be very careful when you are putting the data points into the continuous class interval. Why? Because in these class intervals continuous, only the lower limits are included, upper limits are not included. Okay, so this is the way to write the data in the form of class interval. So in the next class, so now when you have, so you would be having doubt, right? So how to convert these discrete class intervals to continuous class intervals, right? Because continuous class intervals are very important. You will be understanding in the next coming classes that to write the data in the form of histograms, that is another way of representation of data. So we use continuous class intervals, and continuous class intervals are very important. They plays very important role. Okay, so in the next session we will understand, we'll get to know we can convert these discrete class intervals to continuous class intervals. So we'll study that how we can do that, okay, in the next session. Thank you so much, and please like, comment and subscribe my channel. And okay, yeah, thank you.